everybody, and welcome. This is Mark Bashor here, who's going to be your host for today's webinar. Just to kind of recap, today's webinar is entitled Think Smart, and we're going to highlight about 5 different ways to save material and runtime using the Insight software, which, if you don't know, Insight software is the software associated with the premier FDM systems by Stratasys. So obviously we have GrabCAD Print, which is more of a default file processor. It's like processing with your hands tied, but today we're going to look at some of the advanced features in Insight, and most importantly, how we can use those to save material and ultimately save some serious runtime and help you guys get the most out of your investment. So for anybody who doesn't know about GoEngineer, we sell basically a full suite of engineering tools, from 3D design software and then related products such as 3D scanners, 3D printers, desktop metal printers, and to go along with that, we offer a lot of services for data management and really training and other things to help you get the most out of your investment into engineering tools with GoEngineer. So our mission statement: GoEngineer provides design and manufacturing tools with expertise that enables customers to reduce the cost, risk, and time required to go live with new technologies and ultimately new product introductions. I'm looking at the list of the different techniques I'm going to be highlighting today, and I'll give a little background on each. The first one is model as support structures. So if you're very familiar with FDM, you will know that there's, we have to switch. There's 2 tips on the machine, a model tip and a support tip. And as we're building up our support scaffolds, the machine has to switch back and forth between model and support, and there's a certain amount of time and actual purging associated with that swap. So if we can essentially build our support structures out of model material, primarily in the areas where they don't interface or where they won't fuse to the model, then we can eliminate that purging and switchover process and the time associated with it. So as an average, that usually equates to about 30 seconds a layer. So there's some really good savings if we use this technique where it applies. Secondly, we're going to go over enhanced visible surface style and talk about how that can speed things up for us. You may or may not know, so we can control the extrusion toolpath width on Stratasys Vortis systems in the Insight software. And the way the machine physically gets wider toolpaths is by turning the drive extrusion wheels faster. And really that equates to depositing material and building your parts faster. So we'll talk about how to turn that on and how to get the most out of that feature. Next, we'll do super sparse, where we're going to take some custom groups and use that to drive sparse filled large parts well beyond what the system would normally do as a default to get some time and material savings out of that. Then we're going to look at an approach for Z sectioning, whereby we take a part, split it somewhere in the middle, and then we can actually flip the top part around and take a part that would otherwise have significant amounts of supports and make it be virtually no supports. And the final technique we're going to highlight is the no-grow supports, where I'm sure if you've seen this before, where you have maybe one little hole or one little feature at the top of the part, and suddenly the support for that feature or hole grows beyond its own extent, and now we have these huge support fingers cascading all the way back down to the base. And we can use the no-grow supports and the support parameters to eliminate that, keep the supports contained to their boundary, and drop the time off. So with each of these, I'm going to be trying to do a completely live demo in Insight. That said, sometimes processing gets a little bit slow because I'm running the webinar. So in that case, I do have them canned, but I'm going to try not to revert to those and do this all live. And then we're going to capture, I've got a table we're going to analyze that has all of the savings associated with each of these different techniques at the very end. Keep in mind, for anyone who's wondering, I wouldn't think of this as an Insight training, although this will be recorded where you guys can review it later. The fundamentals for each of these techniques are taught in Insight. So if you feel a little bit overwhelmed, I'd recommend maybe you look into the Insight training that GoEngineer offers, and if you're willing to travel to Minnesota, it's also offered there as well. So with that, I'm going to go ahead and dive right into Insight. Bring it over onto the screen here so you can all see it. So for this, I'm going to go ahead and start. This is an L bracket file. If you've been to any of the Stratasys Insight training, it should look fairly familiar to you. I scaled it up to kind of just represent a large widget or some sort of a large part. And all I've done at this point, if you look at the parameters, I'm set up here for a 450 MC, 10 slice, ASA, solid fill, normal surface finish. So this is all kind of very, very basic, typical parameters for someone who's just, trying to do some quick iterative parts for maybe a fit check or a design review or something like that. And what this part represents here in terms of the way it's processed, I'll just go ahead and redo it. This is what we call green flag. So if you don't know, the green flag basically means do everything with completely default parameters, slice, generate supports, run toolpaths, get it done for me. And if we look at the estimate associated with this default parameter, we see 8 hours, 42 minutes. And if I add the model plus the support, I'm somewhere around 25 cubic inches in model plus support total. So again, the first technique we're highlighting is switch model material to support, switch support structures to model material. So if I look at all of the layers in this part, you see that gray. The gray is what we call the support sparse group. It's sparse filler region that is essentially just building up a scaffold for later use. So if I turn off my STL display, right there, we're looking at it actually at that sparse structure. And if I turn my toolpath shading, we can see it a little bit more clearly. But there's the support structure there. So if I pan through this is just kind of an arbitrary scaffolding. And you know what? It can all just as easily be model, and we're going to get some good savings doing that. So the best way to do that is first let's make a custom group, which essentially has all of these same parameters, the spacing between rasters, one contour. The only difference is that it's going to be model material, and we do that by going toolpaths, initiating a custom group, new custom group. And this means, essentially select from template. And one of the templates is support sparse. So when I select support sparse here, it fills in all of these fields here with the exact parameters associated with that support sparse grouping. The only thing I'm going to change is by switching this over to model material and then accept the group. So you see I have group 1 created now. Now again, all this does is create a group. It is not applied anywhere at this time. So I have to go ahead and find where the part starts. So right here is where we're starting, and I'm going to say let's set that as a bottom of the range. And all I'm going to do is hit page up and pan until something, there's actually some portion of this support structure that interfaces with the model. Notice how the panning is slow. That's because I have my shading on. If I turn my shading off, you'll know it's a little less graphics card intensive and do that. So what I want to do is go down to the last area where we have all gray display curves. Okay. So I see, and I'm going to turn off my toolpaths now because I don't really care to see those. I just want to see the gray. So here I have the gray again. So hey, let's make you a range top and view range. And what view range is just showing me this whole range. So now I can select that. Oops, I grabbed some extra stuff there, so let's do deselect by selection. And now I've selected it, add it to the group. Now this stuff here, I tend to not mess with it too much, this yellow grouping, because this is where we're starting to get really close to the model, and if I switch it, the support material to model material, it could become fused, which would be bad news. So I tend to just ignore anything that has the yellow or the green, and when I say green, what I mean is the boundary here in green, which is called a support face. If I turn the shading back on, we see the support face means there's literally model about to build on top of it. So now we're above that. We're back to the all gray grouping. So I will say make a new range, and I'll pan up, keep holding page up, page up, page up, and just go until we see some more of that yellow grouping again. So there it is. I go back down one, set U for a range top, view range. And before I did the drop down, but I grabbed some model, there's a cleaner way to select. We can select by color here. Select dark gray, add it to the group. So looking at the whole part, all I've done is taken these select layers where the gray has gone to the magenta, and I essentially grabbed the parameters, applied it, and at the end of the whole process, we're going to have the exact same part. The only difference is what material is being extruded for the support structure and how many purgings did we do. So if I run that estimate, we see it was originally 8 hours and 42 minutes, and I think about 25 cubic inches of model plus support. Now we're down to 6 hours, 19 minutes. So it's about a 25% time savings. And if I do my model plus my support, this is what kind of confuses people sometimes, is notice model 20, almost 22 plus support 23. So I'm now at 23 cubic inches total. If I switched my support structure to model, how did my model drop? I should have used more, is what intuition would say, right? Well, that's absolutely correct, but because we're not purging, we're actually saving more material than we're using by building the structure out of the model material itself. So we'll see all the numbers in the table at the end of this, but that represents a 7.5% material savings and a 27% runtime savings just by that quick little change. I know I've been talking a lot and it's taken me 10 minutes to show that, but you know, if you brought that up to speed and you were doing this every day, this whole change would take maybe 30 seconds or less from an operator standpoint. So what I'm going to do now is start over and show a little bit different of a technique here. So we'll go bracket default. And this is the original bracket we started with. We see our gray support structures. Now, I'm going to leave that on there. So the build time that we first looked at would still apply here. So that's the 8 hours, 42 minutes and in terms of runtime. So all I'm going to do here now is switch this, this normal surface finish to enhanced. And what that does, let me first... So this is the very bottom layer of the part right here. And if I look at the tool paths and kind of, we'll go tight into a corner and even turn on my shading. If I look at the tool path here and the tool path here, this is my bottom and second layer up. You'll notice that, you know, based on the size of these air gaps, it's the same exact parameter 2 times. If I switch this to enhanced, you're going to see that on that coarser layer, this is the very bottom layer, you actually look at these holes get smaller because my toolpath becomes finer. And if I go up 1 layer and then I rerun toolpaths, you're going to notice the toolpaths get bigger. So like I explained in the intro here, that's doing that by turning the drive wheels faster on the internal layers that you'll never see. So you're building the part faster that way. And I kind of always use an analogy for a coloring book. It's like doing a coloring book but having a wider pen. It doesn't take as many passes to fill in a specific boundary. And our bottom actually looks better because of it, because we have a smaller pen on the first and last page of that coloring book, the pages that somebody's actually going to look at. So from there, I'll even kind of just tweak this out a little more, as I call it. So if I go to Toolpaths, Setup, you see my advanced parameters. You know what, I don't even need advanced, but you see the visible rasters now become 17 thousandths and the internal rasters are 24 thousandths. I can bump this up even a little bit extra to say, oh, we'll do 30 thousandths rasters, and then you'll actually see, them get even coarser. But again, that's fine because you'll never see any of this stuff. It's on the interior of the part. So with these parameters changed, running on enhanced, I'm going to take that same exact part that we just looked at. That was 8 hours, 42 minutes. And I'm going to rerun the estimate. And now we see that 8 hours and 42 minutes is a 7 hour and 5 minutes. And the, you know what, on the example I did, we can even tweak that out a little bit more to, let's go to 032. So, and we see that even 7 drops somewhat more, and we get down to 6 hour 58 minutes from 840. So again, significant time savings just by making that little technique. And to be honest, at the end of the part, we'll have a better looking part because that very first layer and all of the visible layers, like this very last layer, are done with a finer contour toolpath. The other thing that's interesting to mention is that we can actually compound these 2 techniques into one part if we really wanted to, and really double the savings in terms of runtime, because now we're not doing the switching and we're filling the part up faster. So both of those techniques can be applied to the same part in many cases. Next, I'm going to demonstrate a technique for doing super sparse. So in order to get a baseline for this, I'm just going to open up the canned file I have for the default, and then we'll work off of that so I don't override anything. So default sparse. So here we see sparse, normal, etc., toolpaths, estimate time. We get 5 hours and 32 minutes. Notice the model and support, we're at 9.5 plus 2.5, so maybe that's 12 cubic inches total, model plus support. So what we're going to do is create a custom group that's more sparse than the default. And the way I'm going to do that is toolpaths, custom groups again, new. What I want to do is pull in all the sparse fill parameters. So part sparse is what I'm looking for. Whoops, there's part sparse. Okay, that brings in all the parameters. Oh. So part sparse, we're going to turn off the sparse fill though, and we're going to drive the sparse fill, which is at a default 0.1 air gap, to 0.5. And where you want to be careful applying this, and the reason we don't apply this as a default is because it takes several layers to bridge over something with an air gap this large. So what I'm going to do is leave it on a sparse fill for a period of layers before we go to add the cap layers, which are the solid layers. This will make sense as you see me apply it here. So with that, the group is now created, and we just need to add things to it. So starting at the part bottom, again, I'll use my page up and ranges here. Let me turn off my shading so it goes faster. So I want to keep a few solid layers on the bottom. If we do any less than 2 solid layers, it normally will actually stick this to the support bed. So we want to do 2, or in this case I'll leave 3 cap layers. So 1, 2, 3. And then from here I'm going to start the group. So I'm going to go range up. And what I want to do is page up until this feature, okay, this is the top layer of this feature, so we definitely want to keep that, and we'll keep all of these cap layers moving down. And then I want to keep about 10 of the default sparse fill layers, because it's going to take some layers to repair to get to a decent fill on this. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 10 layers, make that the bottom of my range. Now I can add that to the group. And going back to a top view and generate toolpath for this layer. Oops, something's... Okay, I entered the wrong field here. Notice I entered that 0.5 for the air gaps between contours and rasters. That was an oopsie. It should be adjacent rasters. That's why we see that huge gap around the part. And taking another look, there we go. So turning on my shading, we see that we are super sparse beyond there. Then let me go page up. And then we return to our normal sparse fill for 10 layers to kind of rebuild this. And after 10 layers of that, we get something sufficient to cap. So said and done from the outside looking in, this should look exactly like a sparse fill part. We're just going to find that it used a lot less material and took a lot less time to deposit all that less material. So now we can kind of apply it to this next section. So starting here, maybe we'll do a range bottom and use our page up. So I see some cap stuff there I want to keep. So everything below here now I can apply. View range, and now I'll select by color again. It might be easier to do color red, add. So we're going to keep these cap layers. I'm not even going to mess with them. 1, 2, 3, 4, 5. And then we'll go back and set a new range, range bottom. We'll go all the way up till and we'll go keep our cap layers, go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. View range, and all of that can be selected. Here's another way we can select it, is go selection filters to system part curves, and now it's only going to allow me to select part curves, and it leaves my supports right where they were at. So here you kind of see the full part picture. I'm leaving my cap layers. I don't want to override those. I want this part to look, you know, solid and complete when it's all said and done. And then I took a few layers to rebuild that to go from super sparse to regular sparse, and then lastly my cap layers. So running the toolpaths on this, we'll see that the runtime went from 5 hours and 32 minutes to 4 hours and 55 minutes. So that that equates to about a 10% 10% runtime savings and a 24% material savings over the previous version. Obviously, it's very fragile, but if, again, all we're doing is kind of reviewing the form factor of something, and we don't need strength. I'd recommend this to get a little bit more savings out of it. So last two, first we're going to do the Z section, and we're going to use actually this should have all of the same defaults as the one that we just opened. So I'm going to reopen this guy here. And so we're back to the same default start point as exercise 3. Again, that's a 5 hour, 32 minute runtime. But if we notice here, we're building up this giant support structure, and it goes up and up and up and up and up all the way just to support this face in here. So with this technique, what we're going to do is kind of section this off somewhere right here, and then flip that top section around so this whole thing builds without any support at all. And then it could be glued together in literally minutes. We're using like an ABS glue or something like that after the fact of building. But the technique like this, A, saves the hassle of having to worry about support removal, and then of course the time for support removal. And in the case of a sparse part like this, if we put it in the tank, we know it's going to get flooded with the support cleaning fluid and make cleaning, you know, take a little bit longer for it to dry back out again. So using this technique will definitely streamline the process and get us a finished part in hand a lot faster. So the way we're going to do that is jump right to, first I'm going to pick my area that I want to section. I want to quantify that height. So if I run right up to here, I want to do it right before this cap layer. So right there, this is Z equals 1 inch is where I'm going to section this off. So the way I do the sectioning is go to Slice, Section at Z. Section height, I'm going to make 1 inch. And then we have this option to invert the top section. So in this part, that's going to turn the cup, you know, from upside down to right side up, meaning we don't have supports. And then there's this cool way to do offset registration features. I'll take a look at those once we perform the section here. But we can kind of play around with the parameters and the size of the feature depending on the part size itself. If you notice, then we have these two fields here, job name for save and job name for remain. So what this is going to do is branch this off into two separate part files, and then we can essentially combine those later through the fact. So what this is showing the name designation. So we see this top one is going to have that top suffix added, and the bottom one has the bottom suffix added. We're going to remain in the bottom one, and save will be applied to that top one here. So when I hit OK, this happens. And remove supports, naturally, yes, we want to do that. That's the whole point of doing this exercise. So now we see it's selling its saved one as the top, and we notice it's going to add a bottom suffix to the file I'm working in once I hit OK. So you see it just added the bottom right there. With that said, we now have just that bottom piece. You know what? Based on my height here, I kind of messed this up because it's now adding in that feature right there to that. So I want to go ahead and undo, which I can't really undo since I'm in bottom, so I'll reopen the top and redo this. Default sparse. So instead of 1 inch like I did for that Z height, I'm going to make it 0.95. So remove supports, yes. Okay, so we are in the bottom portion now, and that registration feature I mentioned, see that there? So it just kind of does a little offset and adds a little land and then a corresponding groove or socket on the bottom part. We'll see right here when I add it. So I've got the top or the bottom open. Now I want to add the top. So I'll go to Slice, Section, Combine Slice Curve Files, and then we'll browse. And we want to browse for the L bracket default sparse top now. So L bracket default sparse top. And we see a preview of the bounding box of where it's going to stick that. Hit OK. And now we see the bottom and top all in the same part here. We'll just generate supports here. And we see that now this whole cup feature here doesn't have any support. This whole middle section going up doesn't have any support. We only have the support around the bases. And we still have our parameters, sparse, normal fill. And that 5-hour and 32-minute runtime just became 2 hours and 54 minutes. And when our model plus support used to be about 12 cubic inches, we're now down to 9.5 cubic inches model plus support. So pretty good savings. It all builds a lot quicker. It doesn't go in the tank. It doesn't flood with cleaning fluid. And then we have these nice little features here and here to sort of help us align this and give us some good surface area for some ABS glue or something like that to work as we spend 1 minute gluing it together after the fact. Again, this technique can be conjoined with the previous super sparse technique I mentioned, so you can really compound those together to maximize the savings if it fit for that specific scenario that you were building. And because this file is now a little bit played out, I'm going to go ahead and jump to a totally new file, a housing. So here we're going to demonstrate the no-growth supports. Here we just kind of see a typical enclosure top. We'll align it that way, obviously, to minimize support removal. Right now I'm set up ABS, 10 slice, solid fill. So we'll kind of do a default green flag here. And if I went with this, I would see that it took, let it do its calculation here. Okay, I will see that it took 11 hours, 20 minutes to do. And the problem here is we have these little holes at the top. Let me turn my STL display on. These tiny little holes right there, and what's happening is the support structure is starting there and originating, and it kind of grows beyond its periphery and then cascades all the way down the whole side of the part. And with 8 holes or whatever this has, that obviously equates to quite a bit of support and quite a bit of time to deposit it all. So what we can do here is do support, setup, advanced parameters, which is this icon here. And then if we go to our support and we have this grow field, we can change the small only to no, which is going to prevent them from growing beyond their periphery. So with that, I'll delete the existing supports, rerun the new supports. So I see that there's a lot less. One little problem, and this happens sometimes. So notice this part has a little bit of a draft to it. It's about a couple degrees. So for some reason, and this happens, which is why I picked an example that's going to highlight it, we'll sometimes get some stuff that extends beyond, and we'll want to just delete that off because this is just wasteful. It's actually in 2 areas. I don't know why. So the best way to delete that is go to my top, hide my STL display, and I want to go to just after this feature ends here. Right there. Well, right there. So everything below here for these 2 is sort of pointless, so I can say, hey, make you arrange top, go down a little bit, make you arrange bottom, and now I see just for that section, edit, delete, grab those. So you could do it that way. and delete it, but notice I only did just to there because now I'm going to redo supports. Now that that feature isn't there, I can redo support starting at Z height 3.15. So support, setup, advanced parameters, starting height 3.15, and it's going to redo supports below that and in essence wipe out this lingering portion here. So now I have none of those supports extending beyond their periphery, and I'd run toolpaths to that. And what we'll see is, oops, dismiss you. What we'll see is what was originally 11 hours and 20 minutes becomes 8 hours and 10 minutes for a 25% savings in runtime. And our material, model plus support, went from, let's see, it was 19.25 plus 3.5, so it went from about 21 cubic inches total to 18. So we saved another 4 cubic inches or so just by doing that technique there. So again, this is the 5th technique, the no-grow supports, and that prevents those from cascading all the way down. So with that, I'll jump kind of back into to my presentation here. And this is a summary table of everything we just looked at. Again, we'll kind of run through the techniques. The first one was using model as support for the support structures, using the model material instead of the support. So doing that got us from 8 hours 42 minutes to 6 hours and 19 minutes. Again, that's a 27% savings in runtime and a 7% savings in material costs. I think this example here kind of is telling of a lot. Let's just pretend, you know, somebody, your customer, etc., gave you a file at 10 a.m. and said, okay, I need you to build this. If you would have just green flagged it, that part would have been running into the evening to where, you know, let's just say you leave for your work day at 5 p.m. and then your day's over. Starting this at 10 a.m. means this runs till 5:42, and you don't get access to that night build time now. But if we do this one little technique, get it down to 6:19, now our job finishes before 4 p.m. and we have enough time to, you know, queue up the next job and kick the next job off before the end of our workday. So good savings there. Next one, the switching from normal to enhanced surface finish. This has little to no impact on material savings because, you know, we're essentially filling out the same volume, but because we're, you know, squirting it out faster, or back to a coloring book analogy, we're, you know, putting ink down on the page faster, we see 27 or 26% savings in runtime. Doing the super sparse version on the bracket, the super sparse infill driven by the custom group, netted us a 25% savings and 24.5% savings in material costs, 10% savings in runtime. Inverting Z, or the Z section, saved us 19% in materials cost because we didn't have all that support. And then the time used to deposit the support, the switching, etc., saved us about 50%. And then the final example, the no-grow supports, we saved 14% in material because we didn't have to deposit all that support going all the way up the walls, and 25% on runtime because we didn't have to do the switching and we didn't have to spend the time depositing it. With that, that is all of the content that I kind of have planned. Well, with that, you guys can see my email address on there. Feel free to reach out to me with any questions, any anomalies, anything like that. Pretty good with Insight, so if you you know, just see something that, you know, you want to learn more about, shoot it over to me. I'd be happy to engage with you separately and help you get the most out of your Insight as well. So I'm going to sign off now. Thank you all very much for your time, and look forward to working with you all in the future.